So good afternoon everyone. Today's presentation I'm going to introduce you to a .NET library called quartz.net. Has anyone heard of this before? Okay. So let's see what quartz.net is. It's a full-featured open source job scheduling system, and it's written in C#. So it's a port of a very popular project called Quartz. It's another job scheduling framework for Java. Has anyone worked with Quartz? So it's pretty much the same. Okay. So it's basically the same functionality they have provided for .NET developers. So let's go through the basics. In any job scheduler or a scheduler, there has to be three main components. So obviously there has to be a job which will do all the work which you want to do at a certain time, and then there has to be a trigger. So this trigger will actually tell the scheduler or whatever it is in charge to execute that job so that we can get our work done in the desired time. And also we have a scheduler. So obviously this is where all the management happens. So we have to tell the scheduler execute this job at this time, and then it will automatically do that for us. So we can use timers for this as well. So I have a couple of points which will tell you why use quartz.net instead of timers. So the first thing is it has a very flexible, compared to the timers, it has a very flexible way of scheduling, like telling the scheduler at what time this job should get executed. So in timers, we can only set the start time and the repeat interval. We cannot go based on dates or times of day and stuff like that. So that is one pro we have with quartz.net. And the other thing is timer is a thread. Like if you create 5 timers, it will be 5 threads. But when it comes to quartz.net, it will utilize the thread pool. And also with quartz.net, you can manage your jobs and triggers. So with timers you can't. So you will see in the demo, you can give IDs for each job and triggers, and based on them you can manage your jobs and triggers. So these are some of the advantages of using Quartz over timers. So let's have a look at the key interfaces, because this is a .NET library. I don't have much theory to take you through. I'll straight away get into the implementation details. There are a couple of interfaces we have to work with when it comes to quartz.net. So the first one is the iScheduler interface. So this is basically the API for us to talk with the scheduler and do all the work. So this is the main interface. And the other one is iJob interface. So basically in quartz.net, when we want to define a job, we have to implement this iJob interface. So we write all our job related code there. You will see that at the demo. And then we have the iJob details interface. So this is used to define instances of jobs. So yeah, you will see this at the demo. And also we have another interface called iTrigger. So just like the iJob, iTrigger is for triggers. So you can build triggers using this. And then we have a class called Job Builder. So the jobs we define using the iJob interface, we can build them and assign them to a job detail instance using this Job Builder class, and also the same thing in Trigger Builder. So this is where we actually build the triggers. If we know these interfaces, you're good to go with Quartz and do some implementation. So let's see how we can create jobs in quartz.net. So like I told you before, we have to implement the iJob interface. So as you can see, there is only one method in this interface. So that is the execute method. So this is the method which will basically be called when the trigger is fired. So in this case, the hello job this is my job, and all my logic related to this job should be included inside this execute method. And you can see that there is a parameter called context, iJob execution context parameter. So this contains all the runtime information about that job. So a particular job may be it may be triggered by several triggers. So we can pass the specific runtime details through that parameter. And that's about jobs. And as for the triggers, so there are 3 common attributes for all kinds of triggers. So in Quartz.net you have 2 types of triggers. One is a simple trigger, you will see in the upcoming slides, and the other one is based on Cron Expressions. So both these trigger types have these attributes. So you have to give a start time and end time, obviously, and then apart from that you can specify which job is associated with this trigger. So that is optional, but you can give that there as well. And then the other attributes are that these are some special attributes. So you can prioritize triggers. So this is used in case of misfiring, like for instance when it comes to daylight saving or something, we may there is a chance we may miss a particular trigger. So in that case I'm sorry I actually I was talking about this one there. So sorry, the priority attribute we use it because I told you we are using the thread pool in Quartz.net. So assume that we are using only 5 threads in the thread pool, and we have around 10 jobs to execute at the same time. So then we can give the trigger a priority, saying okay, this trigger should execute first, this should execute second, and likewise. So if there are 5 threads available and if there are 10 jobs to be executed at the same time, it will check for the priority, and according to the priority it will execute the job. So if we don't set the priority, it will just randomly take jobs and execute. And then we have misfire instructions. So like I was talking earlier, if we happen to miss a trigger, then there are some misfire policies. So by default they have a smart policy in Quartz.net. So if you want to customize it, you can do that as well. And also it has this special thing called calendars attribute. By using calendars, you can actually tell the trigger which dates, like specific days you want to include in the trigger, or which specific days you want to exclude in the trigger, and likewise. So it's another implementation, but if you wish, you can go ahead with that as well. So I told you that there are 2 types of triggers in Quartz.net. The first one is simple trigger. So this is the most commonly used and the rather the basic kind of trigger there is. So it includes a start time, end time, a repeat time, and a repeat interval. So if you have a look at this, if we take a timer, we can only set the start time and a repeat interval. So here we can tell the trigger start at this time, and if this is optional, end time, we can give an end time as well, and we can say okay, go on for 5 rounds and then stop the execution, and give a repeat interval as well. So I have copied some code for samples because I won't be able to show you guys all the scenarios. So this is a very simple trigger. I have set start and I have given a date there, and it will just start at that time. Start in the sense it will actually execute the job for the very first time at my start time. So that is what is meant by start at time. And here's another example. So this one, a trigger for a specific moment in time, then repeating every 10 seconds 10 times. So here again I have given a start time, and then I can tell the trigger this simple trigger, you have to repeat with 10-second intervals and go on for 10 times and then just stop. And this is another example. So here we can give the start time into the future as well. So we can play around with these triggers, and there are like many possible things you can do with this. So in this instance, what it does is it will it will start now, because as you can see it has not specified a start time. So if you don't do that, it will assume that you have to start it now, and it will start now, and with intervals of 5 minutes it will go on forever until 22, that is 10 p.m. So the other type of triggers is Cron triggers. Has anyone heard of Cron expressions? Okay, so are you guys awake? Okay, so Cron expressions are basically, it's like type of, okay, think of it as a regular expression, only it is used for scheduling. So you can associate time, dates and stuff like that using these Cron expressions. Even I heard it for the first time when I was doing this presentation, so I had to go through some tutorials. So it's kind of interesting. It was a little bit similar to me, just like a regular expression. With the simple triggers, you are kind of limited with what you can do with the triggers. But when it comes to Cron triggers, you can specify like advanced triggers. So for example, if you want to say every 5 minutes between 9 a.m. and 10 a.m. on every Monday, Wednesday and Friday. If you want to specify something like this, with a timer, I think we'll have to write some logic there as well. With a simple trigger, it's not going to be straightforward. But with a Cron trigger, it's really simple, because you can convert this every 5 minutes, this condition, into a simple string. And you can just give it to this trigger, and it will understand and it will execute at that given time. So we can configure it using Cron expressions. So I told you that this particular statement can be converted into a string. So that string is a Cron expression. So it's nothing big. Since no one has heard of Cron expressions, so I'll go through this slide as well. So this is nothing big, it's like really simple. So it's like a string basically. So there are seven sub expressions. So it represents seconds. It's not here actually, but you can include seconds, minutes, hours, day of month, day of week and year. So this year one is optional, you don't need to include it, but we can specify that as well. So you saw in the previous table that there are some special characters allowed for each of these fields. So let's see what they are. This is kind of going out of the topic, but you need to know Cron expressions in order to understand Cron triggers. That's why I'm going through this. So if we have a comma, that means we are separating items. So for instance, if we go back to that table, it has this month field, right? So if you want to build a trigger for Jan, Feb and March only, then we can use this comma. So here in this example, Monday comma, mon comma when comma fry means Monday, Wednesday and Friday. So that is how the comma works. And we have the dash or the hyphen. So that is used for ranges. So if in this example it has used it in the year field. So 2000-2010 means between 2000 and 2010. If we use this in the day of week field, saying MON-FRI, that means Monday to Friday, likewise. And then there is this L expression or special character in this case. So that basically allows you to specify the last something, like last Friday, last month, stuff like that. And then this W, these are like really, I mean, if we are using these stuff, that means the cron expression is really complex. But this W, we can use it to make the trigger identify weekdays. So we can use this and create a cron expression to say the nearest weekday to the 5th of October. So it will calculate, and according to, if it's a Saturday, it's going to be Friday. If 5th was a Saturday, the nearest weekday is Friday, right? Friday the 4th. But if the 5th was, I mean, let's say nearest weekday to the 31st, and 31st is let's say nearest weekday to the 1st of November or something like that, and 1st is going to be Sunday or something, then obviously the nearest weekday is going to be Monday. So like that, there are like some scenarios when it comes to using these two expressions. Okay, so I have created a small cron expression here just to give you the basic idea. So I want to tell a trigger to fire every 6 minutes starting from 9:12 am to 5:37 pm. So this kind of expression can be achieved using cron expressions. So this is like a very sort of not like the best case scenario, but if we have to specify something like this, we can still do it using cron expressions. What we have to do is we have to break them into 3 expressions. So the first one says every 6 minutes from 9:12 to 9:59. So that covers from 9:12 to 9:59, right? And then next comes from 10 onwards. What are we going to do? Here we are going to specify every 6 minutes from 10 to 2. 10 to 4. So that will cover 10 am and 4 pm. And then we are left with 5:37. How can we say stop at 5:37? So that is simple. So here we are going up to 4:59. And here we can give a special condition for the remaining time, that is from 5 o'clock to 5:37. We can say every 6 minutes from 5:37 up until 5:37. So likewise we can specify like different sorts of expressions to fire the trigger. I'll walk you through a small demo, so you will understand the usage of this.
So there is no way to specify that in one expression?
No, this kind of a thing you can't specify, because in a...
What happens, if the last figure was at, let's say, 4:58, and then the last expression, it says to start at 5, right? Will the next one start at 5, 6? 5.
Fires at 5.
Are they like independent executors?
Yes.
Are they independent?
Yeah, sorry, I think I missed that. So I told you these are 3 different cron expressions. So when it comes to quartz.net, what you have to do is we have to specify 3 triggers for each of these expressions. So we are going to say this is executed under one trigger, this is one trigger, and this is one trigger, and we are going to assign the same job for these 3 triggers. So it will basically, even though this will finish at 9:59, the next hour is captured in this trigger. Did I answer your question?
No, Now let's suppose that based on the first trigger, okay. So based on the first expression, it was executed at 9:58.
You mean
the last one?
The last it was fired at 9:58.
9:58. So based on the second trigger, at what time would the docket execute? Sorry, yeah.
10:04.
Why?
Because now.
Because it says start at 10 and repeat every 6 minutes. So it is going to fire at 10:06.
10:06, right? Yeah. Then maybe we should say 9:59 to 4 o'clock or something like that, right? Yeah, I think.
That's why, like, if they are completely independently executed, then that would be.
Yeah, I think there is an issue with this the expression I wrote here. So what I wanted to say is it can be done in multiple expressions. So pardon me for that. There is a issue with this statement. Okay, so we'll go ahead with the demo. It's really simple. What you have to do is I'll just create a console app for this one, and you have to install the quartz.net package. So you can either get the DLL and just refer it here, or we can get it from the NuGet manager. So when installing this, you can see that it's using some other third-party DLLs as well. So this is used for logging. If you prefer to omit the login and do your own login, you can just use the Quartz DLL and just refer it here. But for the demo, I'm just going to go ahead with this. Okay, so it's installed. So the first thing you need to do is you are going to use the Quartz library, and the first thing we should do is create a schedule. So for that we can do using a schedule factory. Okay, and I'm going to get a scheduler now, instance of a scheduler, and the basic thing here is you have to start a scheduler, and in order to once you're done with your work, so if you say when you're going to at the application exit or something, you have to make sure you shut down the scheduler. So you can simply say start scheduler and shut down. So these are like the basic operations you need to do. So I'll just put a put a thread sleeve here, otherwise it will shut down before executing any of the jobs. Okay, so now we have already created our scheduler. What we have to do now is create a job. So I told you earlier that we have to implement the iJob interface. So I'm going to do it here, so everything will be in the same place and it will be much clear. So you can see that I have not yet implemented the execute method. Okay. So now inside this execute method, I have to write the logic specific for this hello job job. So this is considered as one job. So let's say in a system we need to send emails daily and we need to generate some sort of reports. So they have to be two jobs. You have to implement them separately. So for now I just put here. This is my job. It's very simple. It's just going to print hello world, and then we come back to the main method, and before we start the scheduler, we need to I told you that we have to give the scheduler instance of a job, so that the trigger, when the trigger fires, it will execute that work. So here we have to create an instance of that job class using the job builder class. So I say create, and here I can give my job type and just say build. So this will now I have created an instance of the hello job. So but there are some other things we can do. This is okay, this will work. But I told you that one advantage of using quartz.net is that we will be able to manage our jobs and triggers. So this provides us with another with the option of giving IDs for each job and trigger. So we have to give a name for the job, and also we have to mention which group it belongs to. So this has to be unique. So the name with all the jobs within one group has to have a unique name. So we cannot have another job with the same name and in the same group. So I will tell you when this will come in handy. So for now, let's just leave it like this. So now I have created my job. Now I am going to create my trigger. So we use the trigger builder class, and there we just simply create it, and that's it. But again, for triggers, again we can do the same thing. We can give it an ID if we want to. Apart from that, what I'm going to do is, now I'm going to create a simple trigger. So I can say with simple schedule, and here I can say I'm going to give an interval of 2 seconds and say repeat count 5 times. Okay, so we have created a simple trigger. And I can say start now. I don't have to tell this, but it's a good practice, so I'll just put it here.
The jobs and triggers that you create here, do they have a global scope for the entire application? There's a global collection of jobs and triggers.
You mean the ones I created here?
Yes.
Entire application meaning? What do you mean by that?
So you created this class by giving a name, identity, and the group. So can another class in the same application domain, probably in a different thread, can access the same job and check its status?
No, because actually I haven't tried that, but as I think it should not be able to, because we are associating all these jobs and triggers with a scheduler. So I'm creating the instance of that scheduler here, so it should not be able to, but
you are creating the scheduler from a factory.
Yeah. But it will not.
It will just simply return you in instance.
Yeah.
It does not add that scheduler into a global collection of.
No. But there is an advanced feature where we can store these things in a database or like in the RAM or somewhere like that. So using that you can actually retrieve the jobs and the triggers you have actually created. So then I think again we may have to still if we get that, we may still have to tell the scheduler, if we are going to use it somewhere else, we may still have to tell a scheduler execute this job with this trigger. So now I have created my trigger. Now I have to tell my scheduler the connection between the job and the trigger. So I'm going to say schedule job. So this is where I say this job should be fired according to this trigger. So you can give a collection like a dictionary. You can pass a dictionary to this if you want with a lot of jobs and triggers, but for now I'm just going ahead with one job, and I will run this now. It should ideally print hello world every 2 seconds for 6 times. So that's it. Why I said 6 times is I told you earlier that when we say start now, we are actually going to execute this job at that moment. So that will be 1 time, and apart from that we are going to say repeat for 5 times. So altogether it will be 6 times. So that's a very basic example. Let's say we want to pass some data to this job. Like let's say it's like a report generating thing. So for each employee we need to generate a report on some daily basis. Let's say at 12 o'clock in the night with the daily activities. So in that case we want to pass the employee's name to this. So what we can do is we can use there is a like a collection called job data. So we can use that. It's like a dictionary. So you can give key value pairs, and we can access that within the job method. So I'm going to say using job data, and here we can give the key value pair. Yes.
Assume that the job takes like 5 seconds. In that case, does it overjump the other prevent? Does it prevent execute the second one?
It was supposed to be a part of my demo. So there is an attribute called disallow concurrence. I'll show you that. So now I'm going to pass this data to my execute method, and there are two ways we can retrieve this data. So the easiest way is we can create a property which will have the same name of that this parameter thing we pass, right? So it's called name. If I have a property with the same name, then it will automatically map that to this. So in this case, it should automatically map this the value of name to this property. So if I use it here, it should say hello bot. So let's see if it works. Can you guys see? Sure, can change that. So now it takes that property. That is one way of accessing this data. The other one is I told you this context contains all the details of the jobs, the runtime details of the job. So we can directly get it from this context parameter as well. So I'm going to say I'm just going to create another variable here, and I'm going to access that the data we passed through this context parameter. So I have to go to the job detail instance, and from there I have to access the job data map and get the name. So this is another way of doing it. It will basically give you the same output. So that's how you pass values to this method. So to answer Hiran's question, suppose what he asked was, sorry, I didn't hear you. Another job is depending on this one. So there are job listeners, trigger listeners, like they are like events. Like every time you finish a job, it will fire an event and you can capture it there. So with that information, you can pass it to this job if you want to. It's like another feature in this cots.net. So it's included in one of my slides. I'm not going to demo it today though. So basically they are like event listeners. So like a click event, they have trigger listeners, job listeners, and events like that. So Hiran's question was, now I'm in this trigger I have specified to repeat every 2 seconds. So let's say my job is actually going to take like 5 seconds or something. How will cots.net handle that? So if we don't do anything and just let it run, what it will do is, since it's using the thread pool, it will first come to in the first time this fires, it will come to this job and it will basically assign this job to a available thread, right? And then it will wait for 2 seconds, and it doesn't matter if this has finished or not. It will not matter to the scheduler. So the next time it fires after 2 seconds, if there is another thread available in the thread pool, it will assign the job again. So it will just go on overlapping with other things. So I'll show you what I mean by that. So I'm going to say this takes 5 seconds, and to show the job finished, I'll just have something on here.
Is there a way to get the repeat count?
Yeah, I'll show that as well. Okay, so now after the job is finished, it will just print these stars. So we'll see what happens. I think you all get the idea. So it will just execute, right? Like it will just assign the work to the next thread which is available. So what we can, if we don't want that kind of a thing to happen, so let's say this is making some database changes or something, we don't want that to happen, we can tell the job not to do that by using this disallow concurrent execution. So what this does is basically it will tell the job, hey, the next time these files don't execute unless there are no other jobs of the same type running. So in this case, since I use this attribute, what it will do is, it will first time when it fires, it will come to this, it will wait for 5 seconds, and even though there are so many other threads available and the scheduler, the trigger might keep on triggering, it might keep on firing, doesn't matter, it will wait until the first job is finished and then it will move on to the next job. So in this case, I'll make it 4 seconds because 5 seconds, or 3 because it's too long. In this case, ideally, if when I run this, it should finish the first job and then move on to the second job. So you can see that it's happening now. And along with this, to answer Hetu's question, whether we can keep the count, not only the count, like if we want to pass on some data which is executed here or manipulated inside the job method, if we want to pass on that data, we can use this persist job data after execution attribute. So what this does is, once we change the data inside this execute method, we can pass it on to the next time when it fires. So let's say like we are using another parameter to get the count. And here we access that we get that data. And then we want to increase this value, the count value, and bring it on to the next for the next time when it fires. So what we can do is, we can add it to the job data. So this is one way of doing this. This is not only for the count, we can do this for other data as well. But using the trigger listeners also, we can get the count. Specifically, if we just want the count, we don't have to maintain it here. We can just get it from the trigger listener as well. So what this will do is, I have initially got the initialized value of the count, and I'm going to increase it, and I'm going to put it back into this job data map, so that the next time we reach this job, it will get the increased value. So it will be 2. So this is the simple triggers. We'll move on to the cron triggers now. And also, I forgot to mention one thing. So how this job trigger thing works is, you can't assign multiple jobs to the same trigger, but you can do it the other way around. You can assign multiple triggers to the same job, but you can't assign multiple jobs to the same trigger. So that's how it's implemented. I think from what I read, it reduces a lot of confusion and stuff like that. So that's one thing to note in this. It uses the thread pool. It doesn't just because we initialize a job doesn't mean it will allocate it will have a thread for that, but instead what it will do is, when it's time to execute a job, it will assign the work to a available thread in the thread pool.
Is your operating system thread?
Yeah.
It's not create.
No. Okay, so we'll now I will show you the cron triggers. So just like building a simple trigger, we can build a cron trigger. The only difference here is we have to specifically give that cron expression. So I won't be needing this. Instead, I'm going to say it's with the cron schedule. And it's actually very simple and less code. We just have to give the string here. So when I was preparing for this, I found this cronmaker.com website, because I'm also not very familiar with it. This was really helpful. So you can just give the something's wrong with that. So I have prepared for such cases.
To refresh it.
It's okay. This website was down in the morning also. Okay. So I told you earlier at the presentation, we can give various cron expressions. So if you just want to have a look at it, you can use this website. It's really helpful and for you to understand cron expressions. So let me give a cron expression to execute. Now the time is 3:48. So I'll say execute at 3:49 every Monday to Friday. So it should execute today. So the expression is sorry. So to say no 49, it's past. I'll say 50. So Monday to Friday, 3:50 it should execute. This. Okay, I forgot to tell the scheduler that this is the trigger it should adhere to, so it gave me a wrong output. So even though it's a simple string, it still works, and what I felt was that it's really powerful because without too many complicated codes, we can just give, if we construct the string properly, we can do like a really good, like a very complex trigger there without much complexity. And also I had another small example for the cron trigger, so I will show that to you now. So I want to fire my job at 3:51 or something on the first Wednesday of each month. So this is October, right? So today is the first Wednesday of October. So it should fire today. So of course I can't demonstrate to you that it won't fire tomorrow. So you try this out at home. It will not fire. It should not actually. So I'll say. So Wednesday is Sunday, Monday, Tuesday, Wednesday, the fourth day. The first Wednesday. If this doesn't work, we'll just go ahead because I created this expression myself, so it may not work. Every month, so it's like this here. So here we can say the Wednesday, that's Sunday, Monday, Wednesday, and hash. If you can remember, I told in earlier example that hash means the number. So we say every month is not specified anymore. We have just said star, so that means all months, and the first Wednesday. Hash 1 means first. If we put 2 there, it will be the second Wednesday. Likewise. Yeah. So that's for the demo. I think I'm running out of time as well. So I'll go ahead with the demo, the presentation now. So there are some more features in this library. So Malmi asked whether we can, whether if a job depends on another job, how can we handle that? So for those kind of things, we have listeners. So we have trigger listeners, job listeners, scheduler listeners. So they will, like for instance, if you take a trigger listener, it will fire an event when once its assigned job has started executing, because there may be like misfirings as well. So it's kind of helpful if you want to handle those kind of things. These listeners are helpful, and also we can store these jobs and triggers. So we used the identity for each job and trigger. So using that, we can store it either in a database or in the RAM. And also I told you earlier that there are like misfire instructions. So in case you miss a trigger, like a firing time, you can specify what you want to do in that case. So maybe you want to hold it and fire it the next day, or immediately fire it, or whatever. So it's up to you. And it has its not its own, but it uses common login from the DLL. So it supports login as well, so you can configure those things as well. So I just went through their documentation. They have a lot of configurations going on. So this is just one way of implementing it. When I initially started, you can use quartz.net as a service as well. So there is a service, you install it, and you have your DLL deployed there. So then it will automatically trigger those the jobs and continue with the work. You don't have to have the thing up and running for the scheduler to happen. And of course it's used in the thread pool, so we can configure how many threads you want to use and stuff like that as well. And it also supports clustering. I don't have much of an idea about that because it was I don't think it was a free feature, so you have to pay to get that. But it supports itself. So that's like a overall introduction to quartz.net. Do you guys have any questions? What do you think? What do you think about this library?
We use this in the project.
No, we don't. But
But there are similar projects for also we use this
in our project, we have a thing called budget alerts, where we can generate alerts monthly or yearly and give a specific day and stuff. So I was thinking maybe it would have been useful to use this kind of a thing rather than writing that logic. But then again, if your system only requires you to send emails every like midnight, then no point of having another third-party library and doing that. But if you have a lot of scheduling sort of work going on, I think it will be useful.
This only shows the scheduling logic, right? We just don't have to implement the scheduling logic in our application.
Yes.
But everything else we have to
Yeah.
implement, right? Data storage, like the storing of the actual schedules. And when our application runs, we have to load them into memory and create the schedules, create the triggers.
Yeah.
So that part we have to
Good. But the thing which we will not have to do is we can get rid of that extra logic we write to determine, like if it's a Monday or a Wednesday or blah blah blah. Those kind of things.
Logic.
Yeah, the time related logics we can get rid of those things.
So does this also use system timers like in the backend?
I am not sure because it's a Java like thing, so I'm not sure what's using there.
Is the .NET library?
No, it's a port of that Java project, the Quartz.
Yes, you can be using the CLR.
I'm not sure what it uses beneath. So if anyone is interested, they have a very good documentation. So you don't need to A to Z, it's all there in their website. You can have a look at that as well.